Hello, everyone. Thanks for attending It's Automation Meetup Volume 4. Personally, I'd like to thank everyone at Zenitech for inviting me to speak today. It's truly an honor. So, my name is Andrew Knight, or you may know me as Pandy for short. I am the Automation Panda. That means I build solutions to testing problems. Currently, I'm the lead software engineer and test for the Precision Lender product at Q2. The banking software. Be sure to follow my blog at automationpanda.com and follow me on Twitter at automationpanda. If you have any questions or anything after today or just want to reach out to say hello, these are the best places to reach me. So another cool thing is that I'm also the lead developer for Boa Constrictor, which is the .NET Screenplay Pattern. Today, I'm going to introduce you to the Screenplay Pattern as a new way to automate interactions. Now, the Screenplay Pattern isn't exactly new. It's been around for a few years. I didn't create it myself. But nevertheless, it is still new to a lot of folks in our industry. I strongly believe that the Screenplay Pattern is a much better way to interact with web pages than the page object model, which has seemed to have reigned supreme for about the past decade. So, in this talk, I'll back up my claim in 3 parts. First, I'll cover problems with traditional ways of automating interactions. Second, I'll explain why the Screenplay Pattern is a better way. And third, I'll show how to use Screenplay Pattern with a C# library named Boa Constrictor. Pardon me. To start, let's define that big I word I keep tossing around. Interactions. Simply put, interactions are how users operate software. For this talk, I'll focus on web UI interactions, like clicking buttons and scraping text. Interactions are an indispensable way of testing. The simplest way to define testing is interaction plus verification. That's it. You do something and you make sure it works. Think about any functional test case that you have ever written or executed. That test case was a step-by-step procedure in which each step had interactions and verifications. Here's an example of a simple DuckDuckGo search test. DuckDuckGo is a search engine like Google or Yahoo. The steps here are very straightforward. Opening the search engine requires navigation. Searching for a phrase requires entering keystrokes and clicking the search button. And verifying results requires scraping the page title and result links from the new page. Interactions are everywhere. Unfortunately, though, our industry struggles to handle automated web UI interactions well. Even though most teams use Selenium WebDriver in their test automation code, every team seems to use it differently. There's lots of duplicate code and flakiness too. Let's look at the way many teams evolve their WebDriver-based interactions. I will use C# for code examples, and I will continue to use DuckDuckGo for testing. When teams first start writing test automation code using Selenium WebDriver, they frequently write raw calls. Anyone familiar with WebDriver should recognize these calls, whether you program in C# or Java, or basically any other structured language. The WebDriver object is initialized using, let's say, Chrome driver to test the Chrome browser. The first step, to open the search engine, calls driver.navigates.goToURL with the DuckDuckGo website address. The second step performs the search by fetching web elements using driver.findElement with locators, such as shown here, and then calling methods like sendKeys or click. The third step uses assertions to verify the contents of the page title and the existence of the results links. Here, that should be greater than 0 or should contain panda are from the Fluent assertions library in C#. Finally, at the end of the test, the WebDriver quits the browser for cleanup. Now, like I said, these are all very common WebDriver calls. Unfortunately, though, there's a big problem with this particular code snippet. Race conditions. Oh, the dreaded race conditions. There are no less than 3 race conditions in this code, in which automation does not wait for the page to be ready before making interactions. WebDriver does not automatically wait for elements to load or for titles to appear. Waiting is a huge challenge for web UI automation, and it's one of the main reasons for what we call flaky tests, those intermittent failures that sometimes happen and sometimes don't. You could set an implicit wait that will make calls wait until target elements appear, but they don't work for all cases, such as the title in race condition number 2. Explicit waits provide much more control over waiting, timeout, and conditions. They use a WebDriver wait object with a preset timeout value, and they must be placed explicitly throughout the code. Here, they are placed in the 3 spots where race conditions could happen. Each wait.until call takes in a function that returns true when the condition is satisfied. These waits are necessary, but they cause new problems. First, they cause duplicate code because web element locators are used multiple times. Notice how search form input homepage is called twice. Second, raw calls with explicit waits make code less intuitive. If I remove the comments from each paragraph of code, what's left is a bit of a wall of text. It is difficult to understand what this code does at a glance. To remedy these problems, most teams use the page object pattern or the page object model. In the page object pattern, each page is modeled as a class with locator variables and interaction methods. So, a search page could look like this. At the top, there could be a constant for the page URL and variables for the search input and search button locators. Notice how each has an intuitive name: URL, search input, search button. Next, there could be a variable to hold the WebDriver reference. This reference would come via dependency injection through the constructor. The first method would be a load method that navigates the browser to the page's URL. And the second method would be a search method that waits for elements to appear, enters the phrase into the input field, and clicks the search button. This page object class has a decent structure and a mild separation of concerns. Locators and interactions have meaningful names. Page objects require a few more lines of code than the raw calls we saw at first, but these parts can easily be reused. The original test steps can be rewritten using this new search page class. Notice how much cleaner this new code looks. You create this page object for the search page, you load it, and then you perform search for your desired phrase. Other steps can be rewritten using page objects too. Here, I don't even need to show the result page class's implementation. We can just presume that we would have these intuitive methods like wait for title and wait for result links. Unfortunately, though, page objects themselves suffer problems with duplication in their interaction methods. Suppose a page object needs a method to click an element. We already know the logic. Wait for the element to exist, and then click it. What about clicking another element? This method is essentially hard-coded for only one button. A second click method is needed to click the other button. That means that, unfortunately, the code for both methods is the same. The code will be the same for any other click method too. This is copy pasta, and it happens all the time in page objects. I've seen page objects grow to be thousands of lines long due to duplicative calls like this. At some point, some teams will say, aha, okay, I got this. More duplicate code can be solved with more object-oriented programming. And then they'll create the infamous base page class with more objects, or with, pardon me, which is a parent class for all page objects in their project. The base page will have variables for the WebDriver and the wait object, much like the other pages. It will also provide common interaction methods, such as this click method that can click on any elements. Abstraction for the win, right? Child pages will inherit everything from the base page. Child page interaction methods frequently just call base page methods. I've seen many teams stop here and say, this is good enough. Unfortunately, in my opinion, this isn't very good at all. The base page helps mitigate code duplication, but it doesn't solve its root cause. Page objects inherently combine two separate concerns: page structure and interactions. Interactions are often generic enough to be used on any web element. Coupling interaction code with specific locators on pages forces testers to add new page object methods for every type of interaction needed for an element. Every element could potentially need a click, a text scrape, a check if it's displayed, or any other type of WebDriver interaction. That's a lot of extra code that shouldn't be necessary. The base page also becomes very top-heavy as testers add more and more code to share. Most frustratingly, the page object code I showed here is merely one type of implementation. I'd bet dollars to donuts that your page objects look different than mine. Page objects are completely freeform. Every team implements them differently. There's no official version of the page object pattern. There's no conformity in its design. And even worse, within its design, there's almost no way to force the pattern for good practices. That's why people argue over things like whether locators should be public or private. Page objects would be better described as a convention rather than a true design pattern. There must be a better way to handle interactions than this. Thankfully, there is. Let's take a closer look at how interactions happen. First, there is someone who initiates the interactions. Usually, this is a user. They're the ones making the clicks and taking the scrapes. Let's call them the actor. Second, there is the product under test. For our examples in this talk, that'll be a web app. It has pages with elements. Web page structure is modeled using locators to access page elements from the DOM. Keep in mind, the thing under test could also be anything else, like a mobile app, a microservice, or even a command line. Third, there are the interactions themselves. For web apps, they could be simple clicks and keystrokes, or they could be more complex interactions, like logging into the app or searching for a phrase. Each interaction will do the same type of operation on whatever target page or element is given. Finally, there are objects that enable actors to perform certain types of interactions. For example, browser interactions need a tool like Selenium WebDriver to make these clicks and scrapes. Let's call these the abilities. Actors, abilities, and interactions are each different types of concerns. We could summarize their relationship in one line. Actors use abilities to perform interactions. Actors use abilities to perform interactions. This is the heart of the screenplay pattern. In the page object convention, page objects become messy because concerns are all combined. The screenplay pattern separates concerns from maximal reusability and scalability. So let's learn how to screenplay using Boa Constrictor. Boa Constrictor is an open source C# implementation of the screenplay pattern that my team and I developed at Precision Lender. It is the cornerstone of Precision Lender's end-to-end test automation solution. It can be used with any .NET test framework, like SpecFlow or NUnit. The project has a rich documentation site hosted on GitHub Pages, and the GitHub repository is named Q2ebanking/Boa Constrictor. You can also grab the NuGet package, which is named boa.constrictor. Let's rewrite that DuckDuckGo search test from before using Boa Constrictor. As you watch this talk, I recommend just reading along with the code as it appears on the screen to get the concepts. Trying to code a log in real time might be a challenge. After this talk, though, you can take the official Boa Constrictor tutorial to get hands-on with the code. To use Boa Constrictor, you'll need to install a couple packages: Boa Constrictor, REST Sharp, and Selenium WebDriver. My example code will also use Fluent Assertions and Chrome Driver. The actor is the entity that initiates interactions. All screenplay calls start with an actor. Most test cases need only one actor. The actor class optionally takes two arguments. The first argument is the name, which can help describe who the actor is. The name will appear in logged messages. The second argument is a logger, which will send log messages from screenplay calls to a target destination. It's like a publish subscribe. Loggers must implement Boa Constrictor's iLogger interface. And console logger is a class that will log all messages to the system console. You can define your own custom loggers by implementing iLogger. Abilities enable actors to initiate interactions. For example, an actor needs a Selenium WebDriver instance to click elements on a web page. Read this line in plain English. The actor can browse the web with a new Chrome driver. Boa Constrictor's Fluent-like syntax makes its call chains very readable. Actor.can adds an ability to an actor. Browse the web is the ability that enables actors to perform web UI interactions. Browse the web.with provides the WebDriver object that the actor will use, which in this case is a new Chrome driver object. Boa Constrictor supports all browser types. All abilities must implement the iAbility interface. Actors can be given any number of abilities. Browse the web simply holds a reference to the WebDriver object. Web UI interactions will retrieve this WebDriver object from the actor. Before the actor can call any WebDriver-based interactions, the web pages under test need models. These models should be static classes that include locators for elements on the page, and possibly URLs. Page classes should only model structure, though. They should not include any interaction logic. Screenplay Pattern separates the concerns of page structure from interactions. That way, interactions can target any element, maximizing code reusability. Interactions like clicks and scrapes work the same regardless of the target element. The search page class has two members. First member is a URL string named URL. The second member is a locator for the search input element named search input. A locator has two parts. First, it has a plain language description that will be used for logging. Second, it has a query that is used to find the element on the page. Boa Constrictor uses Selenium WebDriver's by queries. For convenience, locators can be constructed using the statically imported L method. With our page model set, let's move on to interactions. The screenplay pattern has two types of interactions. The first type of interaction is called a task. A task performs actions without returning a value. Examples of tasks include clicking an element, refreshing the browser, and loading a page. These interactions all do something rather than get something. Boa Constrictor provides a task named navigate for loading a web page using a target URL. Read this line in plain English. The actor attempts to navigate to the URL for the search page. Again, Boa Constrictor's fluent-like syntax is very readable. Clearly, this line will load the DuckDuckGo search page. Actor.attempts to calls it a task. All tasks must implement the iTask interface. When the actor calls attempts to on a task, it calls the task's perform as method. Navigate is one of the tasks, and .toURL provides the target URL. The navigate task's perform as method fetches the WebDriver object from the actor's ability and uses it to load the given page. Search page.url comes from the search page class we previously wrote. Putting the URL in the page class makes it universally available. So those are tasks. The second kind of interaction is called a question. A question returns an answer after performing actions. Examples of questions include getting an element's text, location, or appearance. Each of these interactions returns some sort of value. Boa Constrictor provides a question named value attribute that gets the value of the text currently inside the input field. So read this line. The actor asking for the value attribute of the search page's search input element should be empty. Actor.asking_for calls the question. All questions must implement, you got it, the iQuestion interface. When the actor calls asking for or the equivalent asks for method, it calls the question's request as method. Value attribute is the name of the question, and .of provides the target web element's locator. Value attribute's request as method fetches the WebDriver object, waits for the target elements to exist on the page, and scrapes and returns its value attributes. Search page.searchInput is the locator for the search input field, and it comes from, you guessed it, the search page. Finally, once the value is obtained, the test must make an assertion on it. Should be empty is a fluent assertion that verifies the search input field is empty when the page is first located. Please note, fluent assertions is a separate package from Boa Constrictor. Theoretically, you could use any kind of assertion library together with Boa Constrictor's calls. The test case's next step is to actually enter the search phrase. Doing this requires two interactions: typing the phrase in the search input and clicking the search button. However, since searching is done as such a common operation, we can create a custom interaction for search by composing the lower level interactions together. Search DuckDuckGo task here takes in a search phrase. Its perform as method calls two other interactions: send keys and click. Using one task to combine these lower level interactions makes the test code more readable and understandable. It also improves automation reusability. Read this line in plain language. The actor attempts to search DuckDuckGo for panda. That's concise and intuitive. The last test case step should verify that result links appear after entering a search phrase. Unfortunately, this step has a race condition. The result page takes a few seconds to display result links. Automation must wait for those links to appear. Checking too early, pardon me. Checking too early will make this test case fail. Boa Constrictor makes waiting easy. Read this line here. The actor waits until the appearance of the result page result links is equal to true. In simpler terms, wait until result links appear. Waits until is a special method. It will repeatedly call a question until the answer meets a given condition. For this step, the question is the appearance of result links on the result page. Before links are loaded, this question will return false. Once links appear, it will change to return true. The condition for waiting for the answer value to become true is here. Boa Constrictor provides several conditions out of the box, such as equality, mathematical comparisons, and string matching. You can also implement custom conditions, by implementing the iCondition interface. Waiting is smart. It will repeatedly ask the same question until the answer is met, and then it will move on. This makes waiting much more efficient than hard sleeps. If the answer does not meet the condition within the timeout, then the wait will raise an exception. The timeout defaults to 30 seconds, but it can be overridden. Many of Boa Constrictor's WebDriver-based interactions already handle waiting. Anything that uses a target element, such as click, send keys, or text, will wait for the element to exist before attempting the operation. We saw this in some of the previous example code. However, there are times where explicit waits are needed. Interactions that query appearance or existence do not automatically wait. The final step is to quit the browser. Boa Constrictor's quit WebDriver task does this. If you don't quit the browser, then it will remain open and turn into a zombie. Always quit the browser. Furthermore, in whatever test framework you use, put the step to quit the browser in a cleanup or teardown routine so that it is called even when the test fails. And there we have our completed test using Boa Constrictor's screenplay pattern. All the separated concerns come together beautifully to handle interactions in a much better way. The screenplay pattern can be used for more than web UI interactions too. Boa Constrictor has interactions for REST APIs using REST Sharp. Let's quickly step through a short REST API test. The actor is the same as before. To call REST APIs, the actor needs an ability named call REST API. It uses a REST Sharp REST client with a base URL. For this test, we will use a public API called dog API, which returns random pictures of dogs. One actor can have multiple abilities as long as each ability has a different type. Boa Constrictor uses REST Sharp's REST request objects directly, which specify resource path and HTTP method. To call the REST API, Boa Constrictor uses this call. Actor calls the REST request using the given request object. And this request object will hopefully get a random image of a dog. We can check the response object for response code and other data. Here, we're making sure that the response code is HTTP 200, which in the .NET library is HTTP status OK. This test is quite basic, but Boa Constrictor can do some advanced tricks with REST APIs, like downloading files, dumping responses, and automatically deserializing response bodies. REST API interactions may also be composed together with web UI interactions. As we said before, the screenplay pattern can be summed up in just one line. Actors use abilities to perform interactions. It's that simple. Actors use abilities to perform interactions. For those who like object-oriented programming, screenplay pattern is, in a sense, a solid refactoring of the page object convention. Solid refers to 5 design principles for maintainability and extensibility. I won't go into detail about each principle here because the information is a bit dense. But if you're interested, then snap a quick screenshot and check out each one of these principles later. Wikipedia is a good source. You'll find that the screenplay pattern follows each one nicely. So, why should you use the screenplay pattern over page object convention or raw WebDriver calls? There are a few key reasons. First, the screenplay pattern, and specifically Boa Constrictor, provide rich, reusable, reliable interactions out of the box. Boa Constrictor already has tasks and questions for every type of WebDriver-based interaction. And each one is battle-hardened and safe. My team at Precision Lender uses Boa Constrictor to run thousands upon thousands of automated tests on a daily basis. Second, screenplay interactions are composable. Like we saw with searching for a phrase, you can easily combine interactions. This makes code easier to use and reuse, and it avoids lots of duplication. Third, the screenplay pattern makes waiting easy using existing questions and conditions. Waiting is one of the toughest parts of black box automation, as we know. Fourth, screenplay calls are readable and understandable. They use a fluent-like syntax that reads more like prose than code. Finally, the screenplay pattern, at its core, is a design pattern for any type of interaction. In this talk, I showed how to use it for web UI interactions. The screenplay pattern could also be used for mobile, REST API, and other platforms. You can make your own interactions too. Overall, the screenplay pattern provides better interactions for better automation. That's the point. This is not just another Selenium WebDriver wrapper. It's not a new spin on page objects. Screenplay is a great way to exercise any feature behaviors under test. And as we saw before, the screenplay pattern isn't that complicated. Actors use abilities to perform interactions. That's it. The programming behind it just has some nifty dependency injection. So, if you'd like to start using the screenplay pattern for your test automation, there's a few ways to get started. If you're programming in C#, you can use Boa Constrictor, the library I showed in the examples. If you're programming in Java or JavaScript, you can use Serenity BDD, a mature, complete test automation framework that includes the screenplay pattern. Serenity BDD greatly influenced Boa Constrictor, but please note the two are entirely separate projects. Boa Constrictor is not Serenity BDD for .NET. Instead, Boa Constrictor aims to be a simpler, standalone implementation of the screenplay pattern. If you're programming in Python, hold on to your seats. Python is personally my favorite programming language, and I also think it's one of the best languages for test automation. I'm currently developing a screenplay implementation in Python in my spare time. It will be like Boa Constrictor, but the code will be even simpler because it's Python. If none of those options suit you, then you could create your own. The screenplay pattern does require a bit of boilerplate code, but it's worthwhile in the end. You can always reference code from Boa Constrictor and Serenity BDD because they're open source. If you want to learn more specifically about Boa Constrictor, please visit our documentation site. It provides thorough information about the project and the screenplay pattern. I recommend taking a hands-on tutorial so you can develop a test automation project yourself with Boa Constrictor. It covers both web UI and REST API interactions. Also, since Boa Constrictor is an open source project, I'd love for you to contribute. So, thank you so much for taking the time to learn more about the screenplay pattern in Boa Constrictor today. Personally, I'd like to give special thanks to everyone at my company, Precision Lender and Q2, who helped make this project possible. We released it as open source coming up on a year ago, so it's been pretty exciting since then. So Again, my name is Andy Knight. I'm the Automation Panda. Be sure to follow me. What we'll do now is I'm going to stop the slides, and we are going to actually go hands-on briefly with Boa Constrictor code. So I'm going to X out of here, pardon some of the mess. And here I have Visual Studio open. I recommend using Visual Studio for large-scale .NET development. I know Visual Studio Code is out there, it's popular, it's cool, I've used it myself. But for any time I do my C#-based test automation, I'm in Visual Studio. So here I have loaded the Boa Constrictor solution. This is from the GitHub repository. In fact, I can show that too. Oops. Banking, Boa Constrictor. So if you really want to get started with the project, here is the GitHub pages doc site that I mentioned, and you got a link to the GitHub repository here. And yep, oh wow, we have a Dependabot alert. I'll have to look at that later. But yeah, basically all the code is open source here, and that's all I have loaded here in Visual Studio. So when you look at the solution, you've got the Boa Constrictor implementation. So if you want to actually see how some of the things are implemented, such as the actor class, you can take a look in here, all that good stuff. I'm not going to go step by step through this code. I just want you to be aware of what's here and where it is. But the code I do want to draw your attention to is in the examples project. So like I said before, Boa Constrictor has a full tutorial. It's on that documentation site that I just showed. And if you take the full tutorial, you will step-by-step walk through the building of those two test cases that we saw in the slides. And in fact, there's another test case or two that you'll write that are advanced REST APIs that we did not cover in the slides. The example code for the tutorials is located in the example project, so you can have that for reference as well. If I open up, say, the Screenplay Web UI test, here is what a basic Web UI test for a DuckDuckGo search would look like, not just as a code snippet, but actually in NUnit. NUnit is kind of like JUnit. It's a unit test framework using classes where each method can be a test. So this one I do want to step through real quick and run it with you so you can see exactly how Boa Constrictor is used and called. So here we go, public class. I just named the Screenplay Web UI test. Of course, in the real world, you probably give it a more meaningful name. We've imported all the stuff. We've imported 3 namespaces from Boa Constrictor. We need logging, Screenplay, and WebDriver. We've imported our Fluent Assertions library. We've imported the NUnit framework because that'll be our structure for testing. And then we also imported Selenium WebDriver for Chrome. So in our NUnit test, we have a variable to store our actor. The setup method, which is called before each individual test case. This is where we should do things like initializing our actor. As we saw here, this is the same from the slides we just saw. Actor equals new actor. We've given him a name, and we've given him a console logger. In your setup steps is where you should also add any of your abilities. I recommend adding all the abilities you need at the start, and then just using those abilities in the test case. So here, this should look familiar. Actor can browse the web with a Chrome driver. So this initializes a new Chrome driver and makes it be stored in the browse the web ability. Then the actual test case here is where you'll see a lot of these interactions. So test DuckDuckGo, you'll notice right off the bat, the test case is nothing but a bunch of actor calls. Actor attempts to do this. Actor asks for that. Actor waits until something happens. Because Screenplay is your pattern for handling interactions, and test cases are interactions post verification, you'll find that your test case, whether they're test case methods in a framework like NUnit, or they're Gherkin scenarios in a BDD framework like SpecFlow. All of your test steps are just going to become screenplay calls and a little more than that. So here in our test, we have actor attempts to navigate to the search page, actor asking for that value attribute to be empty, actor attempts to perform your search, actor waits until the appearance of your result links are there. So very concise, very nice, very fluent-like. And then finally, the teardown method is that quitting the WebDriver object. So actor attempts to quit WebDriver for browser. And like we said before, we put that in the teardown so that the WebDriver will always be quit, regardless of what passes or fails in the test case. So that's the Web UI test. If we run it really quick, pull it up here. Visual Studio has this thing called Test Explorer that you can see all the different test cases. So I ran it last night and it worked. Let's see if it runs again. And what we should see is Chrome comes up, yep, performs a search, and it closes it down very quickly because it was able to scrape so quickly, and boom, just like that, it runs. So this is really all you need to do to set up testing with Boa Constrictor. You would add the Boa Constrictor package in NuGet, and like if I were to, this one has a project dependency, but yeah, so it's not going to be listed there, but you will see there's a project dependency on the examples for Boa Constrictor. If you're doing your own project, you don't need to check out the Boa Constrictor repository or anything. Basically, you're going to get that as a NuGet package, and it's going to be in your project file. So like I said before, the purpose of Boa Constrictor is to provide a lot of these things out of the box for you, right? Your basic things like quitting a WebDriver or navigating or scraping a value attribute. Those are very repetitive kinds of things that we've encapsulated in these interactions that you can just call. Setup for Boa Constrictor is very simple. You create your actor, you give it the abilities, and then you're basically ready to go. If you want to take a quick look at one of the other tests, like the basic REST API test, very similar setup, right? Similar kinds of imports. Again, NUnit, create an actor variable, your setup, you create your actor, and this time actor can call REST API using a REST sharp REST client with this URL. And here we have two different tests. One of them getting the status code. So we create a request. We use Screenplay actor calls. Call will call any interaction, whether it's a task or a question, and then return the object if there is any. So actor calls the REST request or this, and then this is just a fluent assertion. Or like, let's say we want to actually test the contents of that request. Typically, these would be combined into one method, but due to the way the tutorial was set up instructionally, the example here has them separate. So again, you would have, your request object, you would call the REST request, and here, this type generic for dog response will do the automatic parsing. So it's not just a general object, it's actually a dog response object. And that looks like this. It's just a data transfer object. It's an object with a message and a status as strings. But anyway, then that response, you can see, becomes a dog response object. And so then we have a bunch of fluent assertions. Status code should be okay. The data status message should be success, and the data's message should not be empty. I find that when I do REST APIs, it's a bit more, the type of code you write is a bit more programmatic versus the Web UI test that's more fluent, more prose-like. But I mean, the Boa Constrictor, the screenplay pattern still folds in nicely because requests are still interactions, right? And sometimes we want to say things like call this specific endpoint, but other times in more, let's say we had a chain of requests we needed to make. You could chain them together in one interaction, and it's all just then one thing you can call. So if we were to, let's say, run those basic REST API interactions that we saw, these should run even faster than the web UI tests. Yep, boom. Nothing to see because they're all kind of behind the scenes. But yeah. I guess I'll finish off by saying, if you do want to learn more about Boa Constrictor, definitely come to our documentation page. Here's the link for it. If you just search like Boa Constrictor Screenplay on Google, you'll probably find it. We've got, basic introduction. We've got a quick start guide if you want to know how do you set it up in your project. Basically, it's get the Boa Constrictor package from NuGet and then set up your WebDriver as appropriate. If you're using Chrome driver, you're going to need to put the Chrome driver on your path. Here's that snippet from the tutorial, from the talk we just had as well. The tutorial, it's a 3-part tutorial, takes you about probably an hour to complete. And then if you want to learn more, we have some previous recordings of talks I've given on this before. Also, this one's really cool. Once upon a time, I teamed up with SpecFlow, and specifically with Andy Village, who is their community manager. And we did a 2-hour live stream converting an existing SpecFlow project from page objects to Boa Constrictor, which is really nice. So that's what I've got to share. I guess we can open it up for question and answer now.
Yes, Sandy. So thanks a lot. It was really, really interesting. And of course, we have some questions. So I will probably just read out the question and then you can answer it. Okay, so you have, well, we have one question which was already answered by you. What is the best source to learn screenplay pattern? Would you mind to share any example project? So you did that already. Thanks for that. Second is anonymous question. What is your opinion on using Gherkin together with screenplay?
Oh, I think that's great. Oh gosh, words fail, too much ideas. So that's actually what we do at my company. Internally at Precision Lender, that big test project I mentioned, it's C# with SpecFlow, which uses Gherkin, and Boa Constrictor. It works really, really nicely because you'll write your plain language given when then steps, and then each step definition for one of those Gherkin steps basically becomes a few lines of screenplay calls. So it's, it provides a very nice layering to your solution, where the top level is like pure thought, pure words. The next layer down is the interactions, which are still, very, very readable, but it's the idea of, the imperative, do this, do this, do this. And then the next layer down from the interactions is the actual implementation of the automation code. So you've got that nice layering of your solution. I strongly recommend behavior-driven development. I strongly recommend writing tests using Gherkin. I love given when then format because it follows arrange act assert. I'm a strong proponent of BDD frameworks, especially SpecFlow. And yes, I personally do use Screenplay together with Gherkin. You don't have to, like I showed in the example project. You can use like a traditional framework like NUnit, but you can use it with BDD, and I think it's very, very valuable.
Thanks. So the next question is also from an anonymous attendee. Can I use Boa Constrictor for free?
Yes, it is a free open source project, right? That was, it started as something internal to my company that was proprietary, but I always had a dream when I first started developing it over 3 years ago that I wanted it to be public and open source for anyone to use. And finally, after a couple of years of hacking away at it and improving it, I got the green light from within my company to release it open source. And so my team and I made that happen about a year ago. So yeah, it's on GitHub. Feel free to go get it. You can just, most people who use Boa Constrictor just go to NuGet, import the NuGet package into your project, and then you can use it. If you want to contribute to the project, like you want to add your own interactions or something, or give back in some way, then you go to GitHub, clone the repo, and start having fun with it there. But yes, free open source. I think the license is Apache 2.0. I could be mistaken on that though.
Okay, good to know that. Second question is from Evelina. Can I use screenplay pattern without object-oriented programming? Let's say when using JavaScript.
Well, the design of the screenplay pattern is inherently object-oriented. The interactions, the tasks and questions are they are classes. So in that sense, like, no, you can't. Like, the screenplay pattern in and of itself is an object-oriented design pattern. But can you use it when you make your screenplay calls? Does the code that calls it need to be object-oriented? That answer is no. So, like if you had a JavaScript implementation of screenplay pattern and you just wanted to call your screenplay calls from JavaScript functions, like, you could do that totally fine. So in that sense, however you use it can be as simple as you want it to be.
Okay, thanks. And another anonymous question. So Andrew, you mentioned why to use screenplay pattern, but honestly, are there situations when it's better not to use it?
Are there situations when it's better not to use screenplay? So my opinionated answer on that is the only situation anymore within test automation, black box test automation, that I would not use a screenplay pattern is if one is not readily available for me and I would have to spend a lot of time making it myself. I categorically believe screenplay is superior to page objects, period, right? Like in C#, because we have Boa Constrictor, I would never ever use raw calls or page objects again, because Boa Constrictor is there, it's off the shelf, it's ready to go, it's free, it has all the interactions we need. I would never go back to page objects in C#, right? There's no justification, because screenplay provides everything in a better way. Now, if we were talking about, let's say, like Python, right? Right now in Python, there is no major implementation of screenplay, right? Python doesn't have a Boa Constrictor yet. So in that case, if I were thrown on a Python test automation project and it had a very, very tight deadline and I had to be like, go, go, go now, I would still probably use page objects in Python. But if I had a little bit more time, then I would basically pre-implement Boa Constrictor in Python and use that instead, because I believe the value proposition is just so much stronger.
Okay, so superior and period. I like that part. Okay, another question from Eustace. It's a longer one. And Eustace says that I feel like flakiness and code duplication is not the issue of a page object model. First, can be solved using similar custom weight method, and second, by combining composition and inheritance properly. Would you agree that the problem is not in page object model itself, but in its free form and not so smart interpretations?
If we were to take a nuanced approach, I would mostly agree with that. You can have very, very good page object implementations if people are very, very careful on things. But nevertheless, because page object convention, model, pattern, whatever you want to call it, has a combination of concerns, of locator together with interaction. That combination of concerns is what will originate a lot of that duplication of your code, right? Just like we saw, like you can have those, generic kinds of methods in a base page class for your generic operations like click and scrape, and you can put all of the safety checks and the weighting in there, right? So that those methods are good and they're going to be safe. And yes, that would avoid a lot of your flakiness and your race conditions. But inherently in that design, you still have that combination of concerns. So you still need to puke out different, you still need to puke out the different permutations of the methods and stuff for, combining it together with locators. So because of that still is inherent in page objects. And also, the typical implementation you see on teams of page objects is imperfect, right? Because it is so freeform and it has that combination of concerns, it enables people to give into bad practices, right? Because people will just slap on their own interaction methods for whatever they want, regardless of something's already there that they can use. Sloppy programmers will forget to include, the explicit weights, the safety checks, all that kind of stuff. So that it even if you start with a good implementation, it can disintegrate very, very quickly. So in that sense, like puristically, I would mostly agree, but not entirely. Pragmatically, I don't think I would agree with that.
Okay, thanks for the answer. And another question is from anonymous one. Are abilities such as attempts to asking for provided by Boa, or it should be developed by test automator?
Both. So like I said before, Boa Constrictor provides provides WebDriver based interactions and REST sharp based interactions out of the box. So the browse the web ability we saw and the call REST API ability we saw, both are provided by Boa Constrictor, right? Because they're kind of like those dependency injection holders. But you can make your own abilities. And in fact, I've done that internally in my company. For example, in our test automation solution, we read inputs and configuration metadata about our test environments from Azure Key Vault. We store everything in Azure Key Vault. It's kind of like a safe, secure secret holder. And anytime we need to, or anytime our tests run, in order to get things like usernames and passwords, we will call our Azure Key Vault to get the secrets. That way we don't have passwords floating around. And so to do that, we need to have a client that is authenticated to reach out to Azure Key Vault as a service. And so we created an ability, something like, actor can access Key Vault using, this particular authentication method or this particular, Key Vault name. So we have things like that where we have added extra abilities on our own. So anytime you want to, implement your own kinds of interactions, you're probably going to need a particular kind of ability to go with that as well. So it's the pattern is there. You can do it. Dream big.
Thank you, Andy. We have a few more questions for you, so stay with us. So Eustace is asking again, if you return page object instead of void in page object model methods, you can write method.method.method, chaining those methods in tests. Such chains provide helpful information about navigation and eases the debugging in case when navigation changes as IDE marks such places in red once return type changes. Is there an ability to achieve that with Screenplay Pattern?
So like truly fluent chains of things. I mean, in theory, you could if you made everything a question and just went kaboom, kaboom, kaboom. It wouldn't be as concise as it would be in page object model. Personally, I'm not as big of a fan of very, very long fluent chains that would change secondary state like that. I know some people, like especially in the Java world, you see things like this, dot this, goes on and on and on and on and on like that. Some people like that. Personally, I actually don't think it's as debuggable. I think I'm more Pythonic in that sense. I kind of like to have one step per statement go boom, 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 rather than have one expressive call that just goes on and on and on and on. That's a matter of personal preference. Can you do that in Screenplay where it goes on and on and on and on? There might be a way to hack it in, but for most intents and purposes, no.
Okay, thanks. We have two more questions which are related, so I will read them as one. And both are from anonymous attendees. So is the screenplay pattern suitable for beginner automators? And the second one, it seems like you need to be a more skilled programmer to start writing tests using screenplay pattern.
So that's a great question, and certainly a big concern. And I empathize with that. My answer to that is, I think anyone who's doing test automation can use screenplay, whether it's a beginner, an intermediate, or an advanced person. One of the intentions I had behind the Boa Constrictor project was to try to make screenplay simpler and more accessible for everyone. It does have that extra concept of the separation of concerns. Actors use abilities to perform interactions, whereas in page objects, everything is kind of smushed together as one. If we can recognize the separation of concerns and what each of these three concerns plays, then I think it should make screenplay a lot easier to understand and to start using. And that's also why we created a full-fledged tutorial to help people use screenplay, so that even if, like, after this, hour-long talk we have, even if some things are still kind of mushy, I encourage people to go through that tutorial and give it a try, because once they do it hands-on, then the light bulbs will go off and they'll get it, and it should be simpler. Honestly, I think that screenplay makes more sense than page objects, right? It's just that we've had page objects in our industry so long, and they've been so entrenched. And because page objects are free form, it allows people to do whatever they want and feel validated in success, when that's not necessarily the recommended or the best things to do. Whereas screenplay is much more opinionated. It orients you to do things a specific way that are safer, that in my opinion are better. So yeah, I would say no, screenplay should be accessible. It should be easy. Oh, and another thing is, remember, you don't have to, or depending on the language you use, right? You don't have to implement the whole thing yourself, right? If you're already in C#, right, Boa Constrictor is there for the taking, right? You don't need to implement the whole pattern yourself. All you have to do is basically use the pieces that are already there. So that's my take on that. One more thought on that. I will caution that if you Google screenplay pattern, you're probably going to find a lot of articles and materials from about 5, 6, 7, 8 years ago by another group of folks who really invested in the Serenity project. I find those articles to be a little bit confusing myself. They're very, very good, but they're very, very technically dense. You have to to read them and understand them, you have to really marinate over them. And I think a lot of people, when they first hear about screenplay, they go to those resources and they try to learn it, and they feel frustrated because it seems a bit more complex than it has to be. So keep that in mind as well. I've tried to make the Boa Constrictor resources more accessible, more understandable to the average person. So and if you have any questions or get stuck, you can reach out to me anytime. Got my blog, got my Twitter. I'm here to help.
Thanks, Andrew. So one more question from Regimantas. It looks easy and okay for small projects or products. However, can it be easily used for large ones having complex user flows? For instance, even to log in, I need to input 3 fields and select the language, as it cannot be changed later on. Or to perform some business function that takes few different pages and quite few actions. It looks like it would be dozens or even hundreds of interactions. How would you recommend to manage things for such huge project?
Great question. So actually, my philosophy is that that screenplay pattern is better for bigger projects than for smaller projects. Usually I would recommend people, if you're only going to be automating up to 100 tests, then maybe page objects will be okay. But if you've got, large scale, you really need something like screenplay with Boa Constrictor. And I can say that because my project on my team at my company, we have close to 2,000 unique end-to-end tests, 2,000 unique tests running up to 10,000 test iterations per day. It runs multiple times, every commit, whatever. All using C#, SpecFlow, Boa Constrictor, right? It is indispensable, right? Yes, it is high scale. Yes, you're going to have a very, very large project, complex stuff. And we're testing a complex product. This is a banking software application. It's not like, something simple. This is complex. It's got a lot of fields. It's got a lot of users. It's got a lot of products. Like, holy, the way the numbers crunch. Oh man, I don't even understand it all. So yes, Boa Constrictor is meant. It is specifically meant for high scale, large, complex projects. So what does it look like when you start using it? Are you going to have like 1,000 different interactions? Actually, no. Let's just presume right now that we're dealing with a web UI project, and I don't even want to talk about like the REST API hybrid part of it. Let's just focus on web UI interactions. Boa Constrictor already provides, like I said, the basic WebDriver based interactions. Every time you need to click something, you need to get some text of something, get an attribute, find the location of something, whatever. I find that most of the interactions we use are things like text, value attribute, click, send keys, what else? Select. There's, of all the Selenium WebDriver interactions, there's only like half a dozen that get used regularly, and most of the tests that we write are things like, log into the app, create a new opportunity for this thing, set the pricing for this, set this field, set this field, set this field. And so like really, we are calling the same basic kinds of interactions over and over and over again. And they're the ones that are baked into Boa Constrictor. As far as the custom interactions, the custom tasks and questions that we make for approaching 2,000 unique end-to-end tests in our whole project, we probably have close to about 100 unique interaction classes that we've made that are like compositions of lower level interactions. And you might think, well, 100 interactions is pretty large. I think it's actually pretty small compared to the sheer number of tests. I would have expected, if you'd asked me like 2 years ago, how many unique interactions would you expect to have? I would have said ballpark 1,000. In reality, we're looking at ballpark, 100, which for the size of our project is really small. And it's because we rely so heavily on the ones that Boa Constrictor already has, which is really nice, less duplication. We do have a lot of page models, not page objects, but page models being the things like that search page that have nothing but locators. We have tons and tons of locators. I mean, that's probably more in like, we probably have order of magnitude, 50 model classes or so, and locators are probably numbering in the few hundreds, which that would be no different than if you had page object model, So yeah, I mean, any sort of large project is going to have large counts of things, but I have found that with Screenplay, it has made it way, way, way easier to manage. I should even preface, in the early days of this test automation project, we started it in my company 3.5 years ago. We started with page objects, right? We started with page objects, and we used page objects for about the first 100 tests. And already then I could see things coming apart at the seams. And I said, stop, let's learn Screenplay. Oh, this really is better. Let's implement our own because we can't find a good one out there in C#. 2, 3 years later, okay, let's release it open source because it actually works pretty well. So I hope that helps give perspective on how Screenplay can scale high and what kinds of expectations you can have. And to note that, I mean, we have a success story with it that we've proven it does work.
Yes, you really proved indeed. So thanks for that. And another one, I think that it's the same attendee who just wrote 2 questions. So maybe a little bit off topic, but is there a real point of writing Gherkin tests and then writing their implementation in C# instead of writing really readable simple code in C#, and post-scriptum tests would be written in C# but BDD style?
I mean, everybody's going to have to make a decision for themselves, right? Personally, I like to use Gherkin because I like to have a mental separation between test case and test code, right? When we have, I mean, I showed you the example in the tutorial and in the slides of using NUnit as the test framework, and it's NUnit to screenplay calls. And yes, they were readable, right? Yes, they were great. You get all the benefits of screenplay. And so he's like, well, why would I need the Gherkin layer? I found that even with screenplay, the Gherkin layer is nice because what if I want to share my tests with someone who is not a programmer, right? They're not going to be able to read C# code. A non-programmer can't learn Boa Constrictor. You can't expect them to get Visual Studio or Visual Studio Code or go to GitHub or something and just read actor.attempts2, actor.asks4. That's not going to happen, right? I need to have the test case written in a non-code way that I can share, right? So I can share it with my support people. I can copy and paste the Gherkin scenario into a bug ticket when we find a bug to explain in plain language how it happens. Or like another thing that we do at our company, we have to share our test reports with certain clients of ours, right? Because we're in banking. I could say certain things about the banking industry. I'm not going to, but certain customers that are of a certain size require certain things that may seem kind of head scratchy, but we have to share test reports and what our test cases are with this company. And so with SpecFlow, right, there's this tool called SpecFlow plus LivingDoc, where it'll take all of our Gherkin tests and put them in a nice, pretty HTML report that's searchable, navigable, has high-level, test results, but without any of the code, right? And so that way I can generate that artifact and give that to them, and it's our test cases. I don't have to do any extra work to kind of look at a block of C# code and kind of decrypt what that means in English. So yes, there is still reason and purpose to use something like Gherkin or a BDD framework together with the screenplay pattern. Within the testing realm, we can't and we shouldn't be thinking that everything is code, that the one artifact that we should have for our test should be purely in code, because there are people involved in software quality for whom code is inaccessible, right? We need to open accessibility up for all kinds of roles, all kinds of people to contribute to quality. And that's why I like Gherkin, because it enables that. And I compare that together with really good code practices to make it easy to automate things. And I think Screenplay is a great way to, tie that in together.
Thanks, Andy. And we have another. We thought that it's the last question, but we have another from Mihai. So is there something that screenplay pattern doesn't do best at the moment and you feel it will be changed in the near or long future as an improvement? Like if we try thinking of Boa Constrictor with screenplay in 5 years from now, what do you think it will be? Will be expecting some improvements, changes in the upcoming versions?
That is awesome. So great question. I have some thoughts about this. So one thing that I found is a little bit frustrating with Boa Constrictor specifically is trying to come up with good readable names for things, right? Because the syntax forces you to make a very readable name. Like when you say actor attempts to do some task, right? You've got to put that name in there. And then the thing is, the way it's implemented, it's always static builder methods. That's how we can have something like actor attempts to click dot on. Click is the name of the class. Dot on is a static builder method that returns a constructed click object. But that limitation in syntax, or that type of syntax, while it can make things be very readable, like you don't need the new keyword stuffed in there, it does force you to have multi-part calls, right? Click on this, text of this kind of stuff. And when you start to make your custom interactions, then you spend some time scratching your head like, how do I come up with a good name that actually fits the flow of the verbiage here? And that can be frustrating. And it can also create much longer call chains than need to be. So that's one frustration I have. And it's inherent in the limitations of what we're doing within C#, right? In Python, this is not as big of an issue. right? You can have shorter names that flow a little bit nicer. So that's one area I would like to see Boa Constrictor improve, or rather just a general pain point of the way Boa Constrictor went about screenplay in C#. Other kinds of improvements, or maybe not necessarily like something's broken and we need to fix it, but longer term view of the Boa Constrictor project. First of all, I would love to have more people contribute to Boa Constrictor. Right now, it's mostly my team and I who do the stuff, but there have been people from the community. But right now, everything in Boa Constrictor is under one package. It's one Boa Constrictor package that has Web UI, REST API, as well as the core pattern. Let's say we wanted to add a new set of interactions for something like Playwright. Playwright is a web UI testing library, we could say, and it's kind of like an alternative to Selenium. It works more inside the browser. It potentially promises faster speeds with less burden on your systems. If we were to add a set of interactions to support Playwright, we would probably put it in a boa.constrictor Playwright namespace. But within the same package, when you would import that package from NuGet, then you would have Selenium WebDriver stuff together with Playwright stuff, when usually you probably want one or the other. And you'd have to suck in all those dependencies. That then becomes a little awkward. Like, well, if I'm doing Selenium WebDriver, why do I need Playwright dependencies and vice versa? So something I'm thinking about long-term in the future would be possibly splitting apart the NuGet package for Boa Constrictor, where, okay, you could get the Boa Constrictor core package that just has the pattern, right? The actor and the interfaces that go with it for interactions and abilities. And then you would have a package for Selenium WebDriver. You would have a package for REST Sharp. You would have a package for Playwright. And that way you could kind of choose, like a buffet, what are the sets of interactions that you want to use with Boa Constrictor, and you wouldn't be forced to just take everything. So that's a vision I have for the future. I would like to get there. I need help because I don't have a lot of time. I'm busy, but that's why it's open source, it's community, so we can have more people help out too. Great question.
I hope that you'll get bigger community after automated. So Andy, I think that's it. We are out of questions. So I want to thank you on behalf of all of us for a great presentation and answers to the questions from our listeners.